Welcome, learners, to this lesson. We are going to be looking at light and the lenses, lesson number 1. This is lesson number 1 of the topic called light and lenses. This is a Form 4 topic which comes almost close to the end of your syllabus. Remember that after this topic, you will have 2 more topics to go, namely nuclear physics, which is just a very short topic you can cover in just 1 period or so. And then the last topic is radioactivity. So we are almost getting towards the end of the MSc syllabus, which is good because very soon you'll be sitting for your mock exams in preparation for the 2025 MSCE examinations. So I believe you are working hard and also you are studying smart. So once again, my name is Mr. Pochilola. Don't forget to do yourself some favor by subscribing to this channel and also by liking, commenting to what you're learning. When you comment, it gives me the enthusiasm that you're following. So without much ado, without talking too much, let's look at what we are going to be looking at in this topic. This is the topic called light and lenses. It's a Form 4 topic. So it is my expectation that after you've covered the topic in its entirety, you should be able to do the following things. So these are the objectives of the topic, light and lenses. So what is it that you should be able to do when you have fully covered this topic? So by the end of this topic or lesson, you should be able to describe converging lenses and diverging lenses. So these are the 2 types of lenses that are of interest for the time being. Of course, we have different other types of lenses, but for the time being, in this topic, we are going to look at converging lenses and diverging lenses. So we are going to define them, each one of them, and look at their operation, how they behave when light is beamed on them. So you should be able to describe converging lenses and diverging lenses. You should also be able to describe, using ray diagrams, the terms such as principal focus, the optical center, and the focal length of a thin lens. Okay, so these terms are going to come out clear as we go. Let me urge you to keep watching the video and taking notes where you deem necessary. So describe, using ray diagrams, the principal focus, the optical center, and the focal length of a thin lens. When we say principal focus or optical center and focal length of a thin lens, what do we mean? What does it entail? All right. You should also be able to carry out an experiment to determine the focal length of a converging lens. Don't worry, we are going to define a focal length just shortly. So how can you determine experimentally the focal length of a converging lens? You should be able to locate images, to state or describe the location of images formed by thin lenses using array construction method. By the way, this is supposed to be array. Using, this is one word it should have been using array construction method. So locate images formed by thin lenses using array construction methods. These are, I beg your pardon on this, the typo error here. So locate, you're saying by the end of the lesson or the topic, you should be able to locate images formed by thin lenses using array construction methods. You should be able to explain the image formation in the human eye. You are going to appreciate in this topic that your eye is the best camera that has been known to man. It makes pictures. Okay, so how does the eye form images? We're going to cover that in this topic. We will describe the defects of vision in the human eye and how they can be corrected. So defects are basically problems that the eye may develop. And how do we correct those problems? Okay. You will describe the uses of lenses in various optical devices. Starting off the eye is also a device. Cameras. We've also discussed the working of lenses in devices such as the slide projector, the telescope, and others. By the way, devices, they check the spelling here, it's D-E-V-I-C-E-S, devices, not the way it was spelled here earlier on. We are going to solve numerical problems which involve the lens formula and the magnification. All right, so don't worry about the terms magnification, lens formula. They will come out clear as we go along. All right, so those are the objectives which the topic is geared to achieve. Okay, so what is a lens? Mind you that a lens is a singular. When there are several of them, two and or more, you say lenses. Okay. So one is called a lens. Two or more are called lenses. So don't think that because there is an S at the end, then that should be plural, so that one can be called a lens. You know, there's nothing like lens. It is a lens. Lens, one, several of them, lenses. So definition of a lens. What is a lens? We define a lens as a carefully molded piece of transparent material that refracts light in such a way as to form an image. And they operate on the refractive property of light. So the definition is saying a lens is a carefully molded. The word mold means shape. So it's carefully shaped. It's a carefully shaped piece of transparent material. Transparent means allowing light to pass through and also being able to see through. So any material that allows light to pass through and we can see through it is called transparent material. So it's shaped in a way that it can refract light. Remember, refract means bend. So a lens is capable of bending light, a ray of light. The effect of that is the formation of an image. Once again, what is a lens? For the sake of this topic, and for the sake of your understanding of similar material elsewhere, we are going to use the term lens to refer to a carefully shaped piece of material, transparent material, which refracts. To refract means to bend, so it is capable of bending light. You have learned in Form 2 in your junior certificate physics that when a light passes through two different media or material, light bends. Let's say light passes through air and then passes through glass. Light is going to bend at the point where it meets glass, like where the glass and the air meet. So a lens refracts light. So they have what we call a refractive property of light. Not reflective, but a refractive, from the word refract, which means to bend. So once again, the definition of a lens. A lens is a carefully molded piece of transparent material that refracts or that bends light in such a way that it forms an image. So that's the definition. Lenses are made of glass. They can also be made from clear plastic or perspex material. Perspex material. Perspex is a type of glass, clear glass. If you have seen a beaker is made up of special glass called perspex. So that kind of glass is used to make a lens. So lenses are made of glass. They can be made of clear plastic, or they can be made from perspex glass. You find the lenses in a lot of gadgets, but the main ones and common ones are cameras. So you find the lens in cameras, especially optical cameras, even your own, the camera in your phone has a lens affixed in it. The eye, the human eye, spectacles or glasses, the telescope, the microscope, the projectors, the microscopes, both simple and compound microscopes. Hand lenses or magnifying glasses, all those contain lenses. So lenses are very useful devices, so to speak. A camera is not of much use without a lens. So is an eye. An eye cannot function without a lens. The telescopes are basically a collection of, it's an assembly of lenses. They are put together, arranged in a certain order, so that you can view objects that are far off. Microscopes are made of lenses. You find two types of lenses in microscopes, namely what we call eyepiece lens and the objective lenses. So without lenses, these devices are not of use. Let's look at the types of lenses. I mentioned earlier on that lenses are of two types, but you can have different other types as well. The main ones are converging lenses and diverging lenses. Converging lenses are also called the convex lenses. Converging lenses are also called the convex lenses, and the diverging lenses are called the concave lenses. So we are saying there are two major types of lenses, namely convex or converging lenses. Convex lenses are thickest at the middle and the thinnest at the edges, at their ends. You see a convex lens shaped like this. So we are saying they are thick here and thin at the edge. This kind of lens is called the convex or converging. So if you don't want to say convex, just say converging. So a convex lens is fat in the center, in the middle there. It's fat or thick. Thick means fat, you know. And on the edges, it's thin here and there, but come in the middle, it is thick. And another type of lens is a concave lens. Concave lens. A concave lens is also called the diverging lens. Please don't confuse the two. Convex lens is called the converging. Concave lens is called diverging. So these are thin at the middle and the thickest at the ends. So you'll see a concave lens will look like this. So here is thin, but on the edge is thick. It's thick. So I'm sure you got the two different types of lenses. These are the main types of lenses. So, convex lenses or converging lenses can also be of a number of types. For example, here we have this lens here is called the biconvex lens. Bi means two. And since it has two faces, if you cut this in the middle, you see this side is curved. It's curved. This side also is curved. So since there are two curved surfaces, we call it biconvex lens. Another type of convex lens is called plano-convex. Plano-convex. Plano, the first part, plano, is used to mean flat. Plano means flat, from the word plane. Plane is a flat surface. So this end here is flat, while this end here is curved. So the flat side is called the plane, while the curved side is called convex. So the name of the lens, therefore, is plano-convex. While this one here is called convex meniscus. Remember, in Form 1, you learned that a meniscus is just a curve. For example, when you place a liquid such as water in a beaker, the surface is not perfectly flat, it's curved. In case of water, it's curved upwards. So this curved surface is called meniscus. This is called the meniscus. It's called meniscus. So in relation to the lens we have here, this end here is the meniscus. This one is the convex. Therefore, the type of lens is called the convex meniscus. Convex meniscus. So three types of convex lenses. One, biconvex lens. Bi because it has two surfaces that are curved. Plano-convex because it has a flat surface on one end and a curved surface with the other side. And then we have convex meniscus with a curved surface on one side. This side here is curved, and here it has a meniscus. Similarly, concave lenses are also of three types. Namely, we have what is called biconcave. Both faces are curved inwards. Since there are two of them, so we call it biconcave. We have a plano-concave. We have this end which is curved inwards, and this end which is flat. So flat is plano. Concave means the other curve that is curved inwards. And then we have, last but not least, we have concave meniscus. Concave meniscus. Concave meniscus is one that has one end which is curved inwards, this one, and it also has a meniscus the other side. Alright, so for today we stop here. We are going to look at the working of lenses in our next lesson. For now, thank you very much. Like I always say, remember to subscribe to the channel so that when a video is posted, you don't have to miss. You don't have to miss any of the videos, especially now when exams are around the corner. My name has been and is Mr. Paul Chilola. Bye-bye.